Hey everyone, and a huge welcome to the architecture team. I'm so thrilled we get to learn together today. We're diving into this explainer on the absolute fundamentals of multi-agent AI systems. So if you're a junior developer who's just joined us, you are in the exact right place. We're going to unpack exactly how modern, scalable AI is built. We're moving away from relying on just one massive program, and instead we're orchestrating this brilliant symphony of specialized components. All right, let's just get right into it.
Okay, so to make sure we're totally aligned, here's the quick itinerary for our explainer today. We'll start with Section 1, the single agent bottleneck. Then Section 2, meet your AI team. Section 3 covers the high-speed data journey. After that, Section 4, advanced multi-agent coordination. And finally, Section 5, why we build this way.
All right, let's kick things off with Section 1, the single agent bottleneck. So think about what happens when you ask a single AI agent to just do everything. Fetch the data, run the complex math, write a summary. It basically suffers from overloaded reasoning. It becomes incredibly hard to scale and honestly much less reliable, because if it fails at just one single step, well, the whole output crashes. But when we look at the multi-agent advantage, we're comparing that single-step trap to a multi-step workflow. Breaking workflows down gives us modular design, specialized intelligence, and vastly better accuracy and control. We are essentially giving the AI the structure it needs to actually focus, which massively reduces errors compared to those risky one-shot requests.
So the crucial point here is that instead of relying on one massive monolithic model trying to be a jack of all trades, we're designing collaborative networks of specialized intelligence. Basically, a multi-agent system is just multiple specialized AI agents working together to solve a complex task by breaking that massive problem down into much smaller, focused parts. It's a divide-and-conquer strategy. And honestly, it completely changes the game for software architecture.
Moving right along, let's jump into Section 2, meet your AI team.
Now, the best way to grasp this is to literally think of the multi-agent system as an actual human team working together in a corporate office. First, you have your planner. This agent acts as the manager, laying out the overarching strategy. Then you've got the retriever, acting as your dedicated researcher who fetches the exact data you need, usually using a RAG pipeline. Next up is the tool agent. This is your executor, the one who rolls up its sleeves to call external databases or run Python code. And finally, the reasoning agent. Think of this one as your lead analyst, combining all that raw information to generate the final polished logic. You see, you aren't just writing a script anymore. You are literally staffing a digital department.
Let's see how this plays out in Section 3, the high-speed data journey.
Let's see this team in action by watching a real query travel through the system. For instance, let's say a user asks the system to process last month's expense analysis. The planner agent steps in as the manager and decomposes that complex request into a clear sequence of executable actions. Step 1, retrieve the financial data and the receipts. Step 2, calculate categorizations and flag any anomalies. Step 3, generate the final insight report. By mapping out these exact actions for effective task decomposition, the planner totally eliminates the chaos and the high error rates we see with one-shot requests. It makes sure the rest of the team knows exactly what to do and in what exact order.
Visualization, this orchestration flow perfectly shows what I like to call a high-speed journey through a complex information space. It functions just like a perfectly timed relay race, where data is handed off flawlessly, step by step. The user passes the baton to the planner, who maps the route. Then the planner hands off to the retriever to pull the facts, then over to the tool agent to execute the external calculations. After that, the reasoning agent takes that raw data to form a final insight. And wrapping it all up, the coordinator manages the entire flow, making absolutely sure all dependencies are met before delivering that perfect answer right back to the user.
Okay, now that we've got the basics down, let's dive into Section 4, Advanced Multi-Agent Coordination.
These advanced coordination strategies are really what make our systems so incredibly powerful in production. Take iterative planning, for example. Agents can actually dynamically refine their execution plans if they hit a roadblock. Then there's shared memory, which allows agents to share intermediate states so no component is ever working in the dark. We can even have parallel agents running simultaneously to massively speed up processing times, while feedback loops iteratively improve the results as they go. Throw in domain-specific role-based agents and you've built a deeply dynamic intelligence ecosystem. Oh, and a super important tip here. To ensure these interactions remain highly accurate, always remember to tune parameters like your search depth for your retriever agents. You really want to dial that in so they aren't just pulling in a bunch of irrelevant noise.
Now let's talk about structure.
Using a hierarchical framework ensures strict control and flow, which prevents the system from descending into total chaos as it grows. Hierarchical coordination, where you have a single manager agent controlling other specialized subagents, is fundamentally essential for building scalable intelligence systems. Think about it. Without a hierarchy, the bots just talk over each other or end up repeating tasks. But with a manager clearly in charge, you ensure that as you scale up and add more agents, the overarching goal of the user is strictly maintained and efficiently executed.
As junior developers, understanding this balance really builds a strong foundation for our daily work. Just look at these design benefits: modularity, scalability, reliability, and specialization. I mean, those are incredible architectural perks, but they only become a reality if you avoid the common mistakes: writing poor coordination logic, deploying way too many agents that just add unnecessary overhead, failing to implement shared memory, or relying on weak planning. All of that will actively sabotage your system. So definitely keep this at the top of your mind every single time you design a new multi-agent pipeline.
Let's bring everything we've learned together and wrap things up in Section 5, why we build this way.
This final insight really captures the core philosophy you should take away from our time today. Complex problems need structured intelligence. We build multi-agent systems because they give us the precise control, the deep modularity, and the boundless scalability that raw, single models simply cannot provide on their own. By treating AI as a highly structured, collaborative team rather than just one chaotic brain, we unlock an entirely new level of reliability in the software we build.
So I really hope you enjoyed this explainer and our high-speed journey into the architecture. The tools and the frameworks are in your hands now. Now that you know exactly how to build an AI team, what complex problem will you orchestrate first? Keep experimenting, keep breaking those complex problems down into manageable pieces, and never forget the unparalleled power of collaborative AI. Thanks so much for learning with me today, and I will see you on the project board.